I'm Canyon North. You've seen me in such videos such as Chemistry and Rapping, GMC Has It All, and Measurements in Chemistry, Part 4. Okay, this is Chapter 3A for us, and this is your homework assignment for Chapter 3A, always on the first slide of the chapter's notes. Notice it says HChem here. That's for honors chemistry, so you do not need to worry about that. Now, what are the goals that we have here for section 3A? Well, we're going to define the measuring and the properties of the metric system. You're going to become familiar with the base units of the metric system. You're going to use metric prefixes to create different sized metric units. And you will learn to convert between metric units. And you will learn to use bridge notation and unit conversions. Now, we're not going to cover all of that here in this video, but that is the plan that we are going with, because there will be a number of videos that would cover some of this. Okay, so let's begin. You know, the reality is that scientists have to, in order to learn, they have to be able to observe and they have to be able to measure. Okay, and measuring, the whole point about measuring is you are comparing an unknown amount to a standard unit. So something that we don't know, which is why we're measuring, to something that we do know, a standard unit. Well, what do we mean by a standard unit? Well, we can have, for example here, a mass, a weight, if you will. So we have a standard unit. Now the reality is, all measurements are going to have two parts. One, you have to have a number. Otherwise, what's the point of doing the actual measurement? It's not the same as an observation. An observation of a squirrel turning blue when it eats blueberries, that you don't measure with numbers. That is a visual thing that you have seen. That's an observation, okay? But when we're measuring something involving numbers, you're going to have a number and then there's going to be a unit to go with that number. Because if it's just the number by itself, it's not really helpful. So here we have 4.2 grams. Okay, and notice if we didn't have grams, well, 4.2 what? 4.2 apples, 4.2 Republicans, 4.2 Democrats, 4.2 Libertarians, 4.2 presidents, 4.2 pounds, 4.2 kilograms. What are we talking about? So that's why we've got to have a unit in there that tells us what that number is representing. So we have to look at dimensions. And in dimensions, we've got to look at things like length, mass, volume, time, and electrical charge. Those are all dimensions. You've heard of the three dimensions: length, the height, and the width, right? Length, mass, volume, okay. Time is considered to be a fourth dimension, all right, and electrical charge. So every dimension would have a unit to go with it. Otherwise, what's the point? So things like meters, seconds, etc. You could look at miles per hour, feet per second. Those are other examples of that. Okay? Then we have what's called a scale. A scale allows us to make measurements. So we can take that unknown amount and compare it to something that we know. How do I know that my foot is a size 13? My foot is not size 13. But there is a way to measure that against something that we know to be a size 13. Is my foot actually size 13? Okay, well that's why we have a scale. Now the scale is graduated. Well, what do we mean by graduated? It's not that it went to school, okay? It means equally divided into smaller units. So when we look at a measuring cup here, you can see all those lines. That is a graduation. This is graduated. You may remember working with the cylinder, the graduated cylinder, when you did your experiment not too long ago on the density of water in the lab. So you got the idea that we have to measure. If we're going to measure, we got to have some kind of a standard, something that we know, a scale, okay? And that's where we're going to take our unknown and compare it to that scale so we can understand it better, okay? But now there's different scales out there. How do we know which one to use? Well, in the sciences, they use the SI or the metric system. SI is the metric system. SI is short for System International, right here, okay? The metric system originated in France after 1789, French Revolution, okay? It's based on a decimal scale of 10. They chose 10 because that's what they knew, that farmers and people who basically didn't know how to read or write, that they could count up to this many fingers. So that's where everything was based on tens, okay? 10 units because people could count that. Now they did actually try a 10-day week because they said everything involving Christianity we don't want to have to deal with at all. None. Remember in Genesis, 6 days God worked to make everything, and on the 7th day he rested. Notice we don't talk about an 8th, a 9th, or a 10th day. Well, the French revolutionaries said we're going to have a 10-day work week. And that's it. We're kicking out that God system, and that's it. We're going to do the 10-day work week. It was, in fact, a disaster because by the time day number 8 rolled around, people and animals were dropping from exhaustion. They were forced to go back to what God had originally put in Genesis, the 7-day week. 6 days you work, 1 day you rest. Boom. Okay? So God ordained the 7-day week like in Genesis, and that's a really important thing. That there was not man's idea of, oh, everything's going to be based on 10. No, 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 no. Now, why do I make a big deal about the metric system? That's because that's what the scientists use to do their measurements, and it's worldwide, almost completely worldwide. And it's based on units of 10, which makes it easier to do calculations. So, there are 7 basic units. The length is the meter, the mass is the kilogram, the time is the second, the temperature, the absolute temperature, is the Kelvin. But wait, in the metric system you have the Celsius. You're right. The Kelvin extends the Celsius scale to include points below the freezing point of water. That's why. Number of particles is something called the mole. Not mole mole, just the mole. The electrical current is the ampere, okay? And the light intensity is the candela. So we have these different units. Those are the basic units of the metric system, okay? So with that, ladies and gentlemen, these are our basic units that we're going to work with. So with that, we have the metric, aka meaning also known as the System International, unit prefixes. Now what are prefixes? That's what goes before a word. So some of the prefixes are used more often. So like mega is times 10 to the 6th. So when we say a megabyte in the computer, we're talking about 1 with 6 zeros after it, or a million. If we look at kilo, 10 to the 3rd, we talk about 1,000. Now some people would say, oh, but it's a grand. That is true, but when you go look in the newspaper for your cars, okay, and it says 30K miles on it, you see 30K miles way more often than you'll see 30G. Okay, that's just the way it is. That's the metric system. Deci, okay, it's basically 1/10. Okay, centi is 1/100th. Now think, how many cents are there in the dollar? That would be important. So we will work with centimeter, okay? And then we have milli. Milli is 1/1000th, or 10 to the minus 3. Then there's the micro, 10 to the minus 6th. And you guys have heard of nanotechnology, which is a way of saying it's very, very, very small. That's 10 to the minus 9th. So here we said a centimeter is 10 to the minus 2 meters, or 1/100th of a meter. Okay? So with that, okay, these are all the possible metric system prefixes that we have out there. So we have like the terabyte, the gigabyte, the megabyte, the kilobyte, okay? And this is the one followed by that many zeros. When you go the opposite way, like deci, centi, milli, micro, nano, pico, femto, there's yocto, all right, and yada. So when they developed the metric system, they took into account these prefixes so that people would understand it. Now, the general public doesn't use most of these. They'll use like kilo, they'll use centi and milli. That's pretty much it. If you're in computers, you're going to look at tera and giga and mega and kilo more often than not. So that's kind of cool for that. Okay, conversion. Basically, conversion in the metric system or in any system, we're changing from one unit to another. So a conversion factor is the number you use to go from one unit to another. Well, wait, what do you mean by conversion? Well, how many seconds are there in 24 hours? That would be an example. How many seconds are there in 24 hours? And we'll work on that. We will, just not at this moment. Okay, because you're watching this, at another time. Now, when we talk about conversion factor, those are the numbers you use to change from one unit to another. So like 12 inches is equal to 1 foot. 100 cents equals $1. So when you got the person, your friend who says, dude, I found 2,500 pennies in the attic in a jar. Let's go down to Ontario Mills. We're gonna go and catch whatever popular movie it is at the moment, and I'll spring for the popcorn, the soda, and all that. Well, good news, you found the 2,600 pennies, dude. But what's the bad news? That's not gonna get you very far. If it's $15 a ticket, you don't even have enough to pay for 2 tickets, okay? You just don't, because 2,600 pennies, how many dollars is it? Well, there's 100 pennies to $1, so 2,600 divided by 100 gives you $26. So if the tickets are 2 for $30, because they're 15 bucks each, you are down by $4. Too bad, so sad. Okay? And then that's when we talk about the bridge notation, and that's a way to multiply and divide several measurements together at the same time. And we'll talk about that a little bit later on, okay? And then this is a way to look at how many seconds are there in a day. That's just the graphical thing, and I'm going to work with you guys on that. And we're going to stop here because we're going to hit chapter 3, measurements. Are there limits to it? For now, let's just go ahead and work with our measurements. Okay, so we've covered the metric system very rapidly. I'm going to have you guys work with the metric system, and I'm going to have you guys be able to do conversions, just conversions in general, but also convert from one metric system unit to another. Okay, all right, that's it. I'm Canyon North, and let's face it, you're not. This is the end of chapter 3A. Bye.